Today we will discuss the methodology of econometrics. That is, what are the steps involved when you are formulating an econometric model. So, when you formulate an econometric model, the first thing you need is you need a theory or a hypothesis. If you have collected data, you can formulate a hypothesis, and based on that hypothesis, you can see whether the data corresponds to the hypothesis. That is, suppose you are saying that the majority of students in a government college, they are girls. You can take that as a hypothesis. You can collect data and see whether your hypothesis is true or not. Or you can start from a given theory, and based on the theory, you can see how the steps involved in econometric model can be discussed. So, we will start with the statement of a theory. So, that is the first step involved in an econometric model. That is, you need to have a theory or a hypothesis, and based on that theory, you are formulating an econometric model. So, like I said, it can be whether you are saying based on your data that the majority of students are girls. That can be taken as a hypothesis, or you can have a concrete theory, an established theory which you can prove based on econometric modeling. Suppose we take as the statement of theory Keynesian consumption function. Keynesian consumption function can be taken as the theory, and you can test this theory based on econometric modeling. So, what is Keynesian consumption function? Keynesian consumption function says that when income increases, consumption also increases, but by less than the increase in income. So, this is the theory we have taken in the econometric model. So, the next step, so the first step in the methodology of econometrics is statement of theory, and the second step is the mathematical. You can formulate a mathematical model based on this theory. The mathematical model which is based on this theory, you can write it as y is equal to beta 1 plus beta 2 x. Y is equal to beta 1 plus beta 2 x, where y is the dependent variable and x the independent variable. Y is consumption expenditure and x the level of income. Beta 1 and beta 2 are parameters of the model. Now, parameters of the model, parameters are different from constants. Parameters, the value of the parameters will vary depending on the function. That is why when y is equal to a plus bx, a and b are parameters. The value of a and b will vary depending upon the slope and intercept. Likewise, here also the value of beta 1 and beta 2 will vary, though they are constants. Where beta 1 is actually autonomous consumption and beta 2 is marginal propensity to consume. So, y is consumption expenditure, beta 1 is autonomous consumption, and beta 2 is marginal propensity to consume. When you draw an econometric model, you have a model like this. That is, it's a regression function. Income on the x-axis, on the y-axis you draw consumption. Then the regression line is drawn where y is equal to beta 1 plus beta 2x. The distance between origin and y-axis, that point shows autonomous consumption, and the slope of the line shows marginal propensity to consume. So, here this marks beta 1. So, when you draw it like this will be beta 1, and the marginal propensity to consume will be beta 2. So, this is a regression line where you can show that theory of the model is expressed in the form of a function with two parameters beta 1 and beta 2. When you talk about it in a geometrical manner, you can say that beta 1 shows the intercept and beta 2 is the slope. When you discuss that in economics, you say that beta 1 is autonomous consumption and beta 2 is marginal propensity to consume. And beta 2 will always be between 0 and 1. Beta 2 lies between 0 and 1. So, this is the mathematical model. Now, in the case of mathematical model, the peculiarity is that you express the mathematical model exactly in terms of theory. So, we have started with the statement of a theory, that is Keynesian consumption function. And this Keynesian consumption function is expressed into a mathematical model where y is equal to beta 1 plus beta 2x, where y is consumption expenditure, beta 1 autonomous consumption, and beta 2 marginal propensity to consume. The peculiarity is that the mathematical model simply expresses the theory. It does not add anything to it. The theory is exactly represented in the form of mathematical equations and functions. That is, when you say that quantity demanded is a function of price, you can say the functional form is QD is equal to function of P, Y, P0, PR, etc. And when you write that in a mathematical form, you can say that QD is equal to A0 plus B1P plus B2 P0 plus B3Y plus B4T. So, the mathematical model simply expresses the theory. The third step is you formulate an econometric model based on this. The econometric model will be y is equal to beta 1 plus beta 2x plus u, where u is the random error term. U is the random error term. That is, here you are considering other factors influencing consumption expenditure other than income. So, consumption expenditure can change not only based on income, it can change based on other factors also, because the size of the family will determine a consumption expenditure. A large size family will have large consumption compared to a smaller size family, or the age group of the family. A family comprising of small children and elderly people will naturally have a higher consumption expenditure compared to another age group. So, the sex composition, age of the family, the size of the family, these are some of the factors. There are a lot of factors which will affect consumption expenditure, but these are some of the factors. Or suppose some kind of change happens in the economy, like in the case of the period of COVID. In the period of COVID, consumption expenditure fell down drastically. So, that was an outside factor which is not taken into account and in normal times. So, all these other factors which influence consumption can be treated as U. This is a random error term, and this can comprise all other factors which influence consumption expenditure. The next part in the methodology is you formulate the model based on data collection. You have to collect data to see whether the theory or how to prove the theory you have stated in the beginning. So, data collection can be done through either through time series, through cross section, or it can be pooled data. Time series data means data collected periodically. It can be month wise, quarterly, daily, based on the period of time. Cross section data means data collected at a point of time, and pooled data means it includes both the ingredients of time series data and cross section data. And based on this data collection, you can estimate the parameters. Now, the parameters are beta 1 and beta 2. The value of parameters beta 1 and beta 2 can be estimated based on regression methods. It can be OLS method, maximum likelihood method, etc., which can be later discussed. So, based on these methods, you can find out the value of beta 1 and beta 2. Suppose the value of beta 1 and beta 2 are given like this. That is, beta 1 is suppose equal to minus 221. Beta 2 is equal to 0.65. Then you can write the equation as y cap is equal to minus 221 plus 0.65x. That is, you are substituting the value of beta 1 and beta 2 in the model. You put y cap. This cap shows that it is an estimated value. The value is estimated, it is not exact. And to show that it's an estimate, you can put a hat, or you can name it as a hat or a cap. So, y cap is equal to minus 221 plus 0.65x. Suppose these are the estimated values you obtained by solving the regression equations. Then this means that the autonomous consumption is minus 221. What does minus sign indicate? That is, you have even if autonomous consumption is, even when the income is 0, there is consumption, and that is the autonomous consumption. So, minus 221 means that indicates borrowings, and 0.65x means 65% of your income is consumed. That is, if your income increases by 1 rupee, the consumption will be 65 paise. Consumption will increase by 65 paise. So, the consumption expenditure will increase by 65%. So y cap is equal to minus 221 plus 0.65x. This is a econometric equation, regression equation, which shows that which shows the values of beta 1 and beta 2. Then you can test your hypothesis. Your hypothesis is that when income increases, consumption also increases, but by less than the increase in income. Here, your marginal propensity to consume is 0.65. So when income increases by 1 unit, consumption expenditure increases by 65 units. So when income increases by 1 unit, marginal propensity to consume, since it is 0.65, consumption expenditure increases by 0.65 units. So our theorem is proved, that is, income increases, the consumption expenditure is less than the increase in income. It's only 0.65. Then, so that is sixth step is hypothesis testing. We have tested the hypothesis and seen that it's true. So we have started with the statement of the theory. We have formulated the theory into a mathematical model. Then this mathematical model, by adding the error term, you convert it into an econometric model. Then you collect data, and based on this data, you can see whether your hypothesis is correct or not. Then this econometric model can be used for predicting or forecasting other variables. That is, suppose you know the value of income. Suppose the GDP is, say, $2,000 million or $6,000 million. Then by substituting the value of income here, you can find out the consumption expenditure in the economy. So suppose you know the GDP or suppose you know the income, you can find out the consumption expenditure. So it can be used for predicting or forecasting data. That is, you always say that what will be the GDP, what will be India's GDP in 2030. You can predict it. You can extrapolate the data from the given known values or known data. So or you say that this is going to be the population of India in 2040. So how do you do this? So you use econometric model to predict what is going to be the population in 2040, what is going to be the GDP in 2030. For all these things, you use econometric models. So that is one of the uses of econometrics. And the last is, it has these econometric models are used for policy implications. That is, if you want to reduce the level of unemployment. To reduce the level of unemployment, you want to increase the consumption expenditure to this particular point. So what targeted income will increase consumption expenditure? So if you know the level of income which will increase consumption expenditure to a particular level, then you can find out this level of consumption. Suppose you know that this level of consumption expenditure, suppose we say that if y is equal to 3,000, the consumption expenditure is 3,000, it can reduce unemployment. That is, if the expenditure increases to 3,000, it can reduce unemployment. So by applying this value of y in the equation, you can find out the targeted level of income which will help you to achieve this consumption expenditure. So by doing this, you can reduce the level of unemployment if you can increase the expenditure to 3,000 whatever units. So these are some of the implications of the model. So when you study the methodology of econometrics, these are the steps to be followed in discussing econometric model.